Here we go. Everybody up here, everybody up here. All right, welcome back. So again, for the people that missed the announcement, there's a funny looking formula down here in purple that will give you a way to figure out what your grade is at this moment in this class. You take 0.9 times your quest grade, you add 0.4 times your homework grade, which for, if you've done all the homework, it's a 25. So if you have done every assignment perfectly, your current homework grade is 25. So you do that calculation, and that will tell you where you are right now. Right after class, I can tell you what your homework grade is if you came in just a minute late today and I didn't tell you. Also, I didn't have a chance to check any homework. I'm sorry, it was math club and then grading or passing out the quests and all that stuff. So I'm going to grade homework, hopefully while people are doing the group activity. I don't want to keep you guys too late today. Okay, so the high grade was a 99. There's one person that got a 99, one person got a 98, and one person got a 97. So there were several people way up there, almost perfect. The median grade is probably more information for you. It's an 84. What does the median mean? Middle. So the word average can mean a lot of different things. When we say average, what most people would say, if I said like 3 and 6, what's the average? You would add them and divide by 2. That's what most people think when you use the word average. The word average means a lot of things. When you add and divide by 2, you are finding the mean of the two numbers. Add and divide by 2. The median is if we were to line everybody up in by their score. So we'll put the person that got 99 first, and then the 98, and then we'll go all the way down to the lowest grade in the class. And we made you stand up here in that embarrassing order, which would be terrible to do that. But if we did that, then the middle person is this median grade. So what that means is that half of the people in this room did better than 84, and half the people did lower than 84. Just to give you a sense of where you are in terms of the class. Katrina. That's right, mode is the most frequent number. Yeah. All right, so, yeah, Davis.
How do the quests work? So if you have this quest, it's something out of 99. Right? This quest, if your grade is
It would be an average of 99.5. So we have a total of 4 quests throughout the year, five quests throughout the year. I don't drop. I just average mean of all 5 grades that you get. Okay. All right, so lots of stuff about the quests, but we start today with new material on page 40. Again, I haven't checked the homework yet, but I will come around and do that later this period. But if we could open to page 40, that's where we begin. And Sam, here you go.
Thank you.
Everybody else has their quest, right? Okay. Last announcement before we dive in. Did everybody get one of these? I put a bunch of pieces of paper, actually SevTap put these on your desk. Did everybody have one of the new calendars? Anybody need one?
Oh, you okay?
Thank you. So, why do we have a new calendar? Snow day. So what that means is everything got pushed down a day. So the date of quest number 2 is different than what was on the syllabus, but I've now printed it, so you have an update. All the quest dates are here, all the test dates are here, the homework assignments, everything is here. This is the new calendar that we're going to use. So what happened at the bottom of this list? Well, I had a day built in. It said to be announced, TBA, assuming that we were going to have a snow day. So we've lost that to be announced day. It was just canceled, and now it looks like that. If we have another snow day, then I'm going to need to think very carefully about dropping a section of material. But at the moment, you guys have the updated calendar, and that's what we're going to go by. So today, we cover additional properties of lines. We're going to see a few lines that have kind of special equations today. That's the goal. So let us begin on page 40. And we'll come up here to number 1, right in the middle of page 40. Question? Monday is a holiday. This coming Monday, there are no day classes. If you anybody have a Monday night class, that is on as scheduled unless the teacher has canceled it. So Monday evening is a regular schedule, but Monday there are no day classes. I was going to announce on Friday, but yeah. Nope, it's fine. Yes?
Something is on the
You can ask me right after class. Okay. All right. Yeah, homework questions, again, I have office hours right after class, every class except Mondays. But I can always take homework questions right after class. All right, so we go here to number 1. It says we start today by exploring horizontal and vertical lines. That's what's going to be a bunch of today. So we're going to consider these 3 points, 7, 2, -4, 2, 0, 2. I'm about to ask you to plot them, but before we plot them, can you just look at those numbers and tell me what they have in common? What's the same every time? Is the y is always 2. So that's what they have in common. The y is always 2. Agree?
Yes.
All right. So part B says plot all 3 of those points. Go ahead and plot 3 points. The y is always 2. Okay, part C. What word describes these points? The line connecting these points. This is a horizontal line, right? Horizontal. Okay, let's move on to part D. It says every point on this line has the form. Okay, which of the numbers was always the same for these points? Was the y, and it was always 2. So every single point on this line has a y value of 2. Is there any pattern for the x's? Looking at those 3 points, could be anything, right? So we're just going to call it x. Any old thing, comma 2, is a good way to describe every point on this line. And if you don't believe me, pick another point that we didn't plot yet. I'll plot it here in black. Pick this point over here. Pick this point over here. Pick any point on that horizontal line. You will find it is something, comma 2, every time. Is there a question?
I was just wondering if you put in plus minus sign
in front of the x? Yeah, so you could put a plus or minus, and I think that's a nice idea because it conveys you could have positive numbers, but you could also have negative numbers. But x for us is general enough that it could be a negative. Yeah, so I think it's already captured in there that we could have all the negatives, but it's a nice thought. Okay, let's find the slope of the line connecting these points. Go ahead and pick 2 points. For example, you could pick these 2 points right here. Do the slope calculation, and let's see what we get. Do you have your packet with you today?
I don't.
Okay, but you have it, you just don't have it with you today. Okay. There you go. Good. Okay, good. Right here. Okay, so slope, how do we find slope? Yeah, so let's do that right now. Okay, slope. First of all, what letter do we use for slope? Yeah, so that's a formula. We're going to use a letter to indicate we're doing slope. And then we've got formulas for it. You can do something like y1 minus y2 over x1 minus x2. You can think of it as a rise over a run. Whatever you do, you're going to subtract y's on top and subtract x's on the bottom. So let's subtract the y's. So I'm going to do the y's. I'll do 2 minus what? 2 divided by downstairs. Minus 7. And upstairs we get 0. Downstairs, negative, careful, negative 11. And then how much is 0 divided by anything?
0.
It is 0. So the slope of this line right here is 0, which is a perfectly good number. What we're discovering here is that the slope of a horizontal line is 0. Right? It doesn't matter where that line is. How much is the rise between any 2 points?
0.
None, right? You don't rise at all. If you decided you were going to walk from this point to this point, you rise 0, and then you run some number, 4, 11. It doesn't matter because the rise is going to be 0. And 0 divided by anything is 0. Let's come down here to F. It says write an equation for the line that passes through these points. Okay, I know that we have been using y equals mx plus b, and to be honest, you can continue to use it for this equation, but I'd really rather not. I want us to think of horizontal and in a minute vertical lines as just being their own kind of special lines. Again, what was the defining characteristic about every point here? The y was 2. That's the equation we need to write down. The y is always 2. How do you write that as an equation? Y equals 2. That is how we say y is always 2. So the equation of that line right there is y equals 2. Okay, can you guys take maybe about 2 or 3 minutes right now and answer all parts of number 2 with your neighbors? Check in with each other regularly. Okay, so let's come back together and let's think about all these different answers. The consistent theme for these points up here is that the x is always the same. In this case, the x is always 4. And then we plotted the points, and what kind of a special line did we have? A vertical line. And then every point on this line has the form 4 comma something. And again, I'd encourage you to just pick a few more points of your choice, write the coordinates, and you will find that it is always 4 comma something. So we capture that by writing here 4 comma some generic y. And then in terms of the slope, I think there were a couple of questions about it. So let's look at the slope, for example, for these 2 points. I'll put it right here. When I subtract the y's, we do that on top, what do we get? 5 minus 2 upstairs, divided by, subtract the x's, 4 minus 4. Upstairs is 3, but that's irrelevant. Downstairs is how much? It's a 0. And we know that we're not allowed to divide by 0. And anytime you see division by 0, we just use the word undefined. That's just vocabulary. If you see something divided by 0, you say it is undefined. So the slope of this line is undefined. Yes?
When you write out y minus y over x minus x,
Yes.
you always go bottom up for a reason.
When you say the bottom up, what do you mean?
So you did 5 minus 2 over 4 minus 4. I did 2 minus 5. The reason why we start bottom up
I did 5 minus 2 because that's what Katrina said. You do 2 minus 5.
is the same. I get that. I get that it's the same. I'm just curious if there's, because every example that you've done, you always, if you were to do a column of x and a column of y,
Yeah.
and do your subtraction, you always go from the bottom up.
Okay, so the only preference that I ever have, and I guess I never really thought about it, but I think I can vocalize it here, is when I do my subtract y's, I'm going to do it so there's a positive number and just hope that the bottom is also positive. So when you give me an opportunity to do 2 minus 5 or 5 minus 2, I'm going to do 5 minus 2 because I'd rather have a positive number.
The only reason I was asking is because I do it the other way if that was going to come back and bite you.
It will never bite you. Just be consistent, as folks are saying. Yeah. So either way, it's undefined. And then the equation here, again, the characteristic was that the x was always 4. So how do you capture that in an equation? X equals 4. All right? So let's summarize all the stuff that we have here. Oh, and by the way, the undefined slope, again, the slope is a rise over run. When I rise, I'll get some number. I don't know how much. It could be 3. It could be a negative 3. But how much will I run? None. And if I'm running none, then this guy down here is a 0. That's the problem, right? You don't run left or right at all. It's only a vertical. So, big conclusions. The equation for a horizontal line has the form blank. Your choices are x equals a number or y equals a number. Fill in the right one there. Is it x equals a number or is it y equals a number? I'm actually going to write the word a number. Yeah. So, horizontal, does it have the form x equals or y equals? It is y equals. So y equals some number. Don't know what it is. Katrina? Y equals B is good. B is the y-intercept, is true. The slope of every horizontal line. The two choices that we just saw were undefined and 0. Just go back, make sure you pick the right one. These ones are 0. All right, so I guess that makes the second set of questions easier. Every vertical line has the form x equals some number. And the slope of every vertical line, undefined. So, you know, I mean, on the next quest, I'm going to ask you questions like this. What's the slope of x equals 5? Is y equals 2 vertical or horizontal? So how do you know? Well, we just kind of pieced it together, and it didn't take all that long to just figure it out from scratch. So if you're ever not sure, don't just guess. Plot a few points and see if you can figure out what the slope is, or see if you can figure out, is it the x that's always the same, or is it the y that's always the same? Another thing that I can say about the difference between the undefined slope and the 0 slope, I think this might help some folks. All right, I've got uphill lines and I've got downhill lines. What kind of slope do uphill lines have? Definitely positive numbers. Downhill lines, negative. Now let's think about transitioning from the blue to the red. So I'm going to draw a bunch of other lines, not quite as downhill, not quite as downhill, something, and then uphill. Yes? We can transition from all of these negatives to eventually positives. Yes? So one line that isn't uphill or downhill, what word have we used today? Horizontal. What's the one number that's in between all of the negative numbers and all of the positive numbers? Is 0. So it is not at all a surprise that horizontal line, which is between the downhill ones and the uphill ones, has a slope that is 0 between the negative numbers and the positive numbers. Does that make sense? Okay. All right, let's try number 4. Find the equation for each of the lines described below. First one is the x-axis. Special. It's either vertical or it's horizontal. That's the first question. Is the x-axis vertical or horizontal? So I heard each word. The x-axis is the one that goes this way, right? Horizontal. All right. So every horizontal line we've just seen up there, is it x equals or is it y equals? Is y equals. For horizontal, is y equals. Okay, and I haven't really thought about just trying to come up with some memorable way for this. Remember that Johnny Depp silly thing? So I don't know. So horizontal has the form y equals, and you can put an E in the middle and make the word hey, or put an A in the middle and make the word hey. I don't know, something like hey. It's just that horizontal is a y equals. I don't really have anything good. V and x. Vex. I curse this math class. Vex it. So okay, so somehow come up with some silly thing just so it's a connection, right? I mean, I'm hoping that we understand it. But on a test or a quest, if you just need a brute memorization kind of thing, you can come up with something. Okay, so again, we said the x-axis was a horizontal line. Every horizontal line, hey, has the form y equals. So all we need to know is what the y value is for any point on the x-axis. I'll just pick one right here. What are the coordinates of that point at random? 6, 0. Let's pick one more point at random on the x-axis. -1, 0. We see what's always the same. The y is always the same. No surprise, we were expecting to write a y equals. How much is the y at each of those points? It is 0. So another name for the x-axis is the line y equals 0. And I find that a little bit troubling because the x-axis, I'd really like to have the form x equals, but it's not. Okay, let's try the y-axis now. The y-axis is what kind of a line? Vertical. Verticals have the form x equals or y equals? X equals. X equals. We just need to know what x is equal to. Well, if you understand what happened above, then maybe this won't be so hard, but we'll pick a random point on the y-axis. That's 0, 3. How much is the x at that point? It's 0. And if you picked any other point, the x would still have been 0. So again, it bothers me a little bit that there's kind of this crisscross. The y-axis doesn't have the y equals. The x-axis doesn't have the x equals, but it is what it is. Let's try part C. Again, trying to find an equation of the line that has undefined slope and passes through the point 5, -7. Okay, the first clue here, we've got to be detectives, is undefined slope. Right there, it tells you it's either x equals or it's y equals. You need to make that leap on your own. You got the big picture ideas at the top of this page. Undefined slope. Is it x equals or is it y equals? It's x equals. And the only other thing we know is that it hits the point 5, -7. How much is x at the point 5, -7? It is 5. At that point, x is 5. At every other point on this vertical line, x must be 5. Part D, a line that has m equal to 0 and passes through the point 3, 2. Again, we're detectives. The first clue, the slope is 0. You've got the big ideas up above. Slope is 0. There's a horizontal. Is it x equals or y equals? It's y equals. At the point 3, 2, how much does y equal? Equals 2. So these are really standard questions, and they're really easy as long as we understand the big picture ideas at the top. Right? If we have that framework, these are very easy questions. All right, so we're done for now with horizontal and vertical lines. We're now going to talk about thinking about 2 different lines at the same time. These are going to be slanted lines, so it'll be a little different. But we're going to think about 2 lines or more at the same time. So let's go to 6. It says, what word would you use to describe the lines that are graphed at right? I have 3 lines all going uphill. Yes, parallel. Everybody know this word? Those 3 lines are parallel? Super. Now, it might be a little bit hard to see the equations on your paper. I tried to make the font bigger, but I wasn't able to. I'll write it a little bit bigger up here. This is y equals 2x plus 4, y equals 2x minus 1, and y equals 2x minus 8. Just looking at the equations, what pattern do you see is the 2x? And so if I had to think about the 2 versus the minus 8, what is the 2 called in terms of the line? It's the slope, right? We know the mx plus b. So the b could be different. All these b's are different, but the m is always the same. And so the equations have in common, they have exactly the same slope. And so our big conclusion here is right in number 7. 2 lines are parallel if their slopes are equal. It's a fact. Hoping that we buy it just looking at the picture. 2 lines are parallel if their slopes are equal. Why is that the case? Well, so you don't need to write this part down, but suppose that I just picked, say, this point right here and this point right here, and I just wanted to think about slope in terms of walking. How much do we rise? We rise 2. How much do we run? 1. So the slope of that line, rise over run, 2 over 1, which is 2. Okay, now I'm going to pick 2 points on this guy. I'll pick like different points. I don't want to pick exactly the same ones. Maybe you're starting to see what's going on here. How much is the rise? Is a 2, and how much is the run? Is 1. And so those 2 things have exactly the same steepness, right? Because for both lines, you are rising 2 and running 1. And so of course they're going to be parallel. They're doing exactly the same motion, right? And then we can play the same game over here. I'll pick a point way down here and another point. How much do we rise? 2, and we run 1. So the slope tells you everything about how inclined, how steep something is. And if it's the same slope, it's the same steepness. So they're parallel. So let's see what we can do with that knowledge. We'll go to number 8, and can we go to Evan?
The graph of 3x plus y equals 1 shown on the axis. Follow the steps below to break the equation. Find parallel picture line. X is negative.
Thank you. All right, so I'm giving you the graph, and I'm giving you the equation, and then I'm asking you to find something. I want an equation for the line that's parallel to this one and passes through the point -2, 1. Now, I can draw this line much more easily than finding the equation, which is what we're about to do. But let's just draw the line. -2, 1, we can plot that. And then how do I draw? How do I know which line of all the ones that go through that point? How do I know which one to draw? We want the one that's, yeah, we picked the only one that's parallel to the first line. So we can just ballpark that and draw something that looks like it's about parallel. Oh, that's very bad. We can draw something that's roughly parallel and make the point a little bigger. There is a straight, I'm just too lazy to. All right, straight line tool. Let me draw something, how's that? Not good? Okay, so we can draw the line or an approximation of the line pretty easily, but finding the equation is a process, and it is a process I'm going to ask you to do on a quest. So here's the process. In order to think about parallel stuff, we know that slope is important. So the first question is, what's the slope of the original line? Not the one I drew, but the one that was already there. So how do we find the slope of that line? Well, you can count boxes if you want. Pick a couple of nice points that are on the first line. You don't want to guess. I had some people do this on the quest. They looked at a point right there and they made a guess. I don't know, that's maybe 0.3, 0. It could be. It could also be 0.25, right? So we really don't want to guess. You want to pick something that's on the grid. So for example, this point right up here is on the grid. We don't have to guess at that one. And then which one? Right there, right. So, so if you just find 2 nice points that are on the grid, you can find the slope very easily by just counting some boxes. So find the slope by counting boxes. How much is the rise? Negative. I really like that a lot of people said negative. The rise is a negative number because we were actually falling, and the run is a 1, it's positive. So that means that the slope, which is rise over run, -3 over 1, which is just -3. Okay, that's fine. But I gave you the graph here, and to be honest, I didn't need to. So if on a quest or a test, I just give you the equation, I just give you this, but I don't tell you what the graph looks like, then you can't do this to find the slope. We better do something else to find the slope. Our basic equation, our favorite equation for lines is y equals mx plus b. If it looks like that, then we can just grab the slope. It's always that number touching the x. So we need to take this equation and solve for what letter? Solve for the y. Because if you solve for the y, then it's going to look like y equals. So how do you move the 3x out of the way? Subtract 3x from both sides. So here's how we do this without relying on the picture. We subtract 3x from both sides. It disappears on the left, moves over to the right. Now, some of you maybe can just look at that and know what the slope is, like just know what number the slope is. But if you can't, because it doesn't quite look like mx plus b, technically the x part is supposed to be the first part. Right now our x is the last thing. So we just have to shuffle them around. We're not changing anything, we're just reordering. That 3x, was it positive or negative? It was negative, so it better still stay a negative. Was that 1 a positive or negative? Positive, it better still stay a positive. So I'm just swapping the order, but you got to keep the signs exactly what they were. So now it looks good to me because it looks like mx plus b. And how much is m? M is -3, right? Yeah, and that's comforting because we got -3 relying on the picture. But I need us to also be able to do it with only the equation. Questions on calculating the -3? Okay, so this next thing that I have written here, let's cross it off. I actually don't like that because I think most people prefer the mx plus b equation to the other one. And tell me if I'm wrong, but that was the point slope version, y minus y1 equals m times x minus x1. I'm just going to ask for a quick vote. If you had to only pick one of these that you were more comfortable with, raise your hand if it's the mx plus b. Everybody has to vote for one. Raise your hand if it's the y minus y1 equals m times x minus x. No. Are you good at both? Yeah, that's good. But my inclination, I think, was right, that most people are gravitating towards the first. So forget the point slope. Let's just do the mx plus b version. What is the slope of the original line? -3. What's the slope of the line that I drew, which is parallel? It's also -3, right? This is the only place where we use the fact that parallel lines have the same slope. So the slope, how about I do this? M of the desired line, the slope of the desired line is also -3, right? The slope of the original line was -3. We calculated that. But because the line we were asked for is parallel, that's the one we desire, that line, it's also -3. Okay, so then we can go back to our mx plus b version. So y is equal to mx plus b, but I'm going to erase the m. What number is our m for the desired line? It's also -3. I'll put it here in green. So the line we're after has equation -3x plus something. What's the only piece of information from the problem we haven't used yet? Is the point, the -2, 1. So now at this stage, we're ready to plug in those numbers for the x and the y. Instead of y, how much is it at our point? 1 equals -3 times, how much is the x at our point? -2 plus the b. Take a moment, solve that for b. How much is b? -5 is good. And so that means that our final equation, y equals -3x plus b plus -5, I'll just write subtract 5. And at this point now, I'm finally really embarrassed about my approximation because that -5 we just calculated is information. Where should we see the -5 on the line that I drew? What does that -5 mean? Is the y-intercept. So the line that I drew should have hit the y-axis at -5, and we didn't quite get there. Yeah, we didn't quite get there. It's okay. Are other questions on this process? I'm going to ask you to do this. I'll give you a chance to practice today, but any questions right now? Okay, next page. Can we go to David, number 9?
Two perpendicular lines are graphed below. Points 0, 4. Lie on L1.
Mm-hmm. Okay, so I know that the axes on your photocopy are not quite as dark as they are up here. But I've given you 4 points, right? See the dots on your graph? And I've given you the coordinates of those points. So the first thing I want you guys to do is find the slopes of each of the 2 lines. So use those coordinates. You don't even need to see the picture, but use the coordinates from the sentence. Find 2 different slopes. Okay, so for our 2 slopes, L1 has a slope of negative 2/3. L2, positive 3/2. Yes? Okay. And the word that Dave mentioned at the very start of this one is that these 2 lines are what with respect to each other? They're perpendicular. What that means is that the angles are how much? Yeah, they're all 90s, like all the way around are 90-degree angles. If you've seen geometry, maybe you've seen like a little square thing. That's how we indicate it's a 90-degree angle or right angle. I'm not so interested in that, but hopefully we can see that these are not just any old arbitrary intersecting lines, but rather these lines meet at angles that are all the same, right? Whereas this angle right here is a lot smaller than that angle over there. The 4 angles in this picture are all exactly the same. They're all 90 degrees. Okay, so big idea here, looking for a relationship between these 2 slopes, negative 2/3, positive 3/2. What's the relationship? Reciprocal is a great word. Everybody know the word reciprocal? Sam, what does reciprocal mean? Inverse fraction. Does everybody know what inverse fraction means?
Yes.
Okay. So in plain English, flip the fraction over, right? Okay. Well, you used exactly the right words. So we flipped the fraction over, but more than that, what else did we have to change? Is the sign. One of them was negative, the other is positive. Do you believe that? If we have any 2 perpendicular lines, one of them is going to go uphill and the other one's going to go downhill. Right? Just imagine, like just keep, like use your arms. Yeah, it could be the special case, right? We could have the one special case where it's a 0 and an undefined slope. But for everything else, one line is going to go uphill and the other one's going to go downhill. No matter how I rotate my arms, as long as I keep them perpendicular, one up, one down. Evan.
I just have a question about the.
Yes.
I'm looking at
When you're looking at which one?
negative 1 and I see like 0 x.
0. Can you come up here and point? Which one are you looking at?
Just this guy right here.
Yeah, this point right here.
Yeah.
Uh-huh.
And I don't know. I'm just.
So that's the point 0, negative 2.
Right.
And your question is about increasing, decreasing?
No, just I don't know, because like when I set up my equation,
Yeah. So let's.
So I'm gonna carry on. I'll try to do
Okay. Yeah, but here are the 2 points in purple, and this is the L2 equation, the bottom one there. Yeah. So try doing the subtract and see what we get. Okay. All right. So putting this all together, the relationships that we saw, one positive, one negative, and the fractions were reciprocals or inverses or flipped over, right? 3/2, 2/3. Okay, so at number 10, we capture that generally speaking. So let's go to Dan here in the front. Number 10, please. Okay, and then there's a fancy equation way of writing that, but I'm not so interested in the fancy equation way. I'm interested in the plain English way. So if you have perpendicular lines, what you're going to do is change the sign and flip the fraction. Change the sign and flip the fraction. And what I mean by that is that if I tell you, for example, that the slope of my one line is negative 2/3, and I want you to figure out the slope of the other line, you change the sign and you flip the fraction. It used to be negative. What does it become? Positive. It used to be 2/3. you flip it over 3/2. Great question. What if the slope of one line was just a single number, not a fraction? Yeah, you make it a fraction by forcing a 1 downstairs, and then you can flip it. Katrina. Negative is just another word for saying opposite, saying change the sign. What's that? Opposite reciprocals is a synonym. It's perfectly good. Okay, so let's try number 11 here. It says write the equation for the line perpendicular to y equals negative 3x minus 2 and passing through the point 1, 3. So this is just going to be a procedure that we follow. It's not going to be very interesting, but I'm going to ask you to duplicate it. So let's make sure we're all on board with the process. So step 1 is to find the slope of the given line. Always start with the slope of the line that I give you. And I'm hoping we can just look at it. What is the slope of that line? It's negative 3. Right? It's just a number sitting in front of the x. Slope of the given line is negative 3. So that means that the slope of the desired line, the one that we're asked for, so we got to change the sign and we have to flip it over. So we do two things. So we change the sign, it becomes positive. Flip it over. This was, this was Savtap's question. 1/3 is the slope of the perpendicular. Okay. It's not a -2 right now. It's an unknown. The slope of our line is 1/3. Yeah, but it has nothing to do. Our y-intercept has nothing to do with the y-intercept of the given line. So this is where we've written y equals mx plus b, plugged in the m that we just calculated, and now we get to use this thing right here. So you plug in the 1 and the 3 for the x and the y. So instead of y, 3 equals 1/3 of 1 plus b. Okay, this one's kind of messy because it has fractions, but we can handle that. Let's just push through. So 1/3 times 1 is just 1/3. How do we move the 1/3 over? Subtract it. So I'm just going to write 3 minus 1/3, but then we're going to write that in a better way. Okay, the easy way is to say that this is 2 2/3. But as you go up in terms of the math classes, you stop writing things with as mixed numbers. That's what this is called. And to be honest, I'd prefer to avoid decimals too. I think fractions are, they're often the way to go. So I'm hoping somewhere in your past you were able to calculate that 8/3. So then I think we're good. We just have to recopy this guy, updated. That sounds good to me. Questions on the process? It's a bunch of steps, but I'm hoping there's some kind of common threads you can grab onto here. I'll say it again in English. First thing you got to do is find the slope. Find the slope of the line that's given, then turn that into the slope of the line that you're asked for. For parallel lines, what's the relationship between the slopes? Same. For perpendicular lines, it's more complicated. Change the sign, flip the fraction. Then you write your basic mx plus b business, but you plug in the m that you just found, And then finally, you got to figure out what B is by plugging the point into your equation. And then recopy it at the end. It's always that process. I'm not saying it's a short process. It's a lot of steps. But with practice, processes that have a lot of steps become more natural and easier to follow. So let's see if we can practice for 20 minutes right now. I realize I'm skipping just a tiny bit that's in the notes, but jump to the group activity on the very next page and work together like you always do. There is an answer key, but check in with each other as well as the answer key.